Okay, so in lesson 1 we talked about how we could come up with rules for sequences and series, and we did this by creating tables just like we did in our warm-ups, numbers 1 and 2, and trying to find a rule that works for all of the columns. If you know you have an arithmetic sequence, we can use a formula that we have that will help us find the rule for that sequence without having to necessarily create a chart every single time and try to play back and forth with how to find the rule. So I'm going to share with you what that rule is, or the formula for that rule, and then we're going to put that to a couple examples into some use. So a rule for an arithmetic sequence is the nth term of an arithmetic sequence with your first term being known as your a sub 1 and your common difference, and we talked about this before in your example 1, your common difference is the pattern, basically the pattern of your sequence, we're going to notate that as D, can be found using the following rule. A sub n, so that's how we start our rule, is equal to our first term, a sub 1, plus n minus 1 times d. If we rewrite this, which it may look a little funny like this, we can also write this as a sub 1 plus d times the quantity or the grouping n minus 1. This is actually distributed first when we're going to be working on these rules. So that you can either write it this way or this way. It means the same thing. Here the d is at the very end, here's the d is at the front, but either way you're going to be distributing this group when you're working with your rules for your arithmetic sequences. So let's look at example 2 together. In example 2, we want to write a rule for the nth term of the arithmetic sequence 20, 18, 16, and 14. Once we find the rule, we then want to find what a sub 9 means. Okay, so let's break this down. What are they asking us? The first is they want us to come up with the rule for our arithmetic sequence. That's the first thing. They want us to come up with a rule knowing that we have that sequence. Then we want to find the 9th term once we have that formula. Okay, so the first thing we're going to do is we're going to come up with the rule. And to do that, we're going to use this equation up above. So our first step, so I'm going to write here step 1, we're going to find our first term. Okay, in order to be able to use this equation, and I'm going to rewrite it here, a sub n is equal to a sub 1 plus d n minus 1. There's pieces of information that we need to know. So we're going to find, in step 1, we're going to find that piece of information. The first is we want to find what your a sub 1 is and what your common difference is, your d. Those are the two pieces of information we need to find. Obviously, looking at our sequence, we know our first term is 20. And from our sequence, we know that from each previous term to our new term, we are subtracting 2. So our common difference is going to be minus 2, or negative 2, because we're getting smaller. Okay? Once we know what that is, what our a sub 1 is and our d, we can plug that into our rule over here, plug it into our formula to get our overall general rule. So I'm going to, step 2 is plug in values. We'll do that over here. So a sub n stays open because that's our general rule, that's what we're leaving open, is 20 plus negative 2 times n minus 1. The reason I put negative 2 in parentheses is because I'm going to be distributing the negative 2 to each of these inside terms. I didn't want to mess up with the plus just yet. So if I continue to simplify, I get 20 plus, and then negative 2 times n gives me a negative 2n. Negative 2 times negative 1 gives me a positive 2. Positive minus, those can simplify to a negative 2n plus 2. And then I can take my two constants and add them together. So I get a sub n is equal to 22 minus 2n. And that's my rule. Alright, so now that I know what my rule is, now I need to do so this step 2 is plug in. Step 3, well, we'll say plug in values